In Section 5, we'll talk about 3 different data collection methods. The first method is a published source. So it might seem obvious what a published source is, but it could be any book or journal or newspaper, for example, and now it could be some article off the internet. So any type of written source is a published source. The second type of data collection method is the designed experiment. So with a designed experiment, a researcher exerts full control over the units. Now, the units could be people, objects, or things in the study. These experiments typically involve a group of experimental units that are assigned the treatment, and then there's also an untreated or control group involved. And finally, the third type of data collection method is the observational study. In an observational study, the researcher observes the experimental units in their natural setting and records variables of interest. Here it's important to note there is no attempt made to control the characteristics of the experimental units sampled. So here the researcher is not going to have groups formed or any control over those groups. And some common examples of observational studies include an opinion poll or a survey of some type. With a survey, the researcher samples a group of people, asks one or more questions, and then records the responses. Now, when the researcher is gathering information using a sample, it is very important that a representative sample is used. A representative sample exhibits characteristics typical of those possessed by the target population. So if the data you're collecting does not represent the population, then your sample would not be a representative sample. With a random sample of n experimental units, this is a sample selected from the population in such a way that every different sample of size n has an equal chance of selection. So sometimes when our subjects are not involving people, just a list of measurements or a set of data, we could use Excel or StatCrunch or some type of program to randomly select data. Otherwise, we have to come up with a way that our sample is truly a random sample. In Section 6, we're thinking more about statistical thinking. What is involved with statistical thinking? And that involves applying rational thought and the science of statistics to critically assess data and inferences. Fundamental to the thought process is that variation exists in populations of data. So we don't expect exactly the same results with every single sample that's taken, but there should be similarities, and it should be a reliable sample. So we know that sometimes there may be bias or error in the data that we collect. So let's look at some of the more common types of error or measurement bias. In the first example, unethical statistical practices occur if biased sample is intentional with the sole purpose of misleading the public. So if a researcher asks a question in a certain way that might be leading the subjects in the study, then that would be considered unethical. Selection bias results when a subset of the experimental units in the population is excluded so that these units have no chance of being selected in the sample. Non-response bias results when the researchers conducting a survey or study are unable to obtain data on all experimental units selected for the sample. And finally, measurement error refers to inaccuracies in the values of the data recorded. In surveys, this kind of error may be due to ambiguous or leading questions in the interviewer's effect on the respondent. Let's see how these type of bias or error may occur. Reference number 7 is about annual survey of computer crimes. The Computer Security Institute conducts an annual survey of computer crime committed at U.S. businesses. CSI sends survey questionnaires to computer security personnel at all U.S. corporations and government agencies. In 2006, 616 organizations responded to the CSI survey. 52% of the respondents admitted unauthorized use of computer systems at their firm during the year. So for Part A, we're going to identify the population of interest to CSI. So the population of interest is the set of all computer security personnel at all United States businesses. In Part B, identify the data collection method used by CSI. Are there any potential biases in the method used? So as far as collecting data, it says that there was a survey sent out. The survey was a questionnaire that was sent out. So that is a type of observational study. So the data collection method used was a survey, which we know is an observational study. Surveys were sent to all computer security personnel at all U.S. corporations and government agencies. However, in 2006, only 616 organizations responded to the survey. So that isn't everybody responding. So there is some type of bias here, and it's what we would call non-response bias, because not everybody who received the survey actually responded. In Part C, describe the variable measured in the CSI survey. Is it quantitative or qualitative? The variable measured in the survey is whether or not there was unauthorized use of computer systems. So whether or not is like a yes-no type of question. So that is not something countable. It's just a yes or no type of response, which means it is qualitative in nature. That is not something measurable on a numerical scale. And last part D, what inferences can be made from the result of the study? So if we assume that the responses were a random sample from the population, we can infer that about 52% of all computer personnel will admit to unauthorized use of computer systems at their firm during the year. So we get this 52% directly from the dialogue above. It says 52% of the respondents admitted unauthorized use of computer systems. So that would be our inference based on the results of the survey. And our last reference question deals with CT scanning for lung cancer. According to the American Lung Association, lung cancer accounts for 28% of all cancer deaths in the United States. A new type of screening for lung cancer, computed tomography, which is CT scanning, has been developed. Medical researchers believe that CT scans are more sensitive than regular X-ray in pinpointing small tumors. The H. Lee Moffitt Cancer Center at the University of South Florida is currently conducting a clinical trial of 50,000 smokers nationwide to compare the effectiveness of CT scans with X-rays for detecting lung cancer. Each participating smoker is randomly assigned to one of two screening methods, CT or chest X-ray, and his or her lung progress is tracked over time. The age at which the scanning method first detects a tumor is the variable of interest. For Part A, we're going to identify the data collection method used by the cancer researchers. So the method used is a designed experiment, and we can tell that it's a designed experiment because there is a clinical trial of 50,000 smokers nationwide. So that is our clue. There's a clinical trial being conducted. Those participating in the study were randomly assigned to one of two screening methods. So that is another clue that we have a designed experiment. For Part B, we want to identify the experimental units of the study. So who is getting the CT scan? Who is getting the X-ray? So the experimental unit in the study are the 50,000 smokers. So up above you can see there's a clinical trial of 50,000 smokers nationwide. Part C, identify the type, whether it's quantitative or qualitative, of variable measure. We have the study is involving the age at which the scanning method first detects a tumor. Age is measured in years, so that is countable data. That would be quantitative data. For Part D, identify the population and the sample. So the population of interest would be all smokers in the United States, while the sample would just be the 50,000 smokers that are participating in this study or this experiment. And finally, Part E. What is the inference that will ultimately be drawn from the clinical trial? So the inference of interest is the difference in mean age at which each of the scanning methods first detects a tumor.